Okay, meet me again, and I'm here to discuss another problem solution for the internal force and internal uh, moment. Okay, the problem that we will discuss today is this particular problem. Okay, so this one, and here I will explain to you guys about how to solve this kind of problem. And the question here is to find out the internal moment and internal shear force distribution. That's the first one. And the second one is to find out the maximum moment, internal moment, okay, and the location as well. So as usual, when we have this kind of problem, we're supposed to start with finding the reaction at A and at B as usual. Okay, at A and at B. Okay, and after we find those values, okay, the next thing that we can do is to do cutting as usual. Okay, and for this kind of problem, because there is a external reaction force at B, okay, like it or not, we will not be able to solve the whole shear force and internal moment distribution by using just one equation. So like it or not, we have to divide it into two because there is a discontinuity. There is a discontinuity at B. Okay, so the next thing that we're supposed to do is to do two cuts. The first cut is here. The second cut is here. Then after that, after we find out the equation for the internal shear force distribution and internal moment distribution, what we're supposed to do is just like the previous video, we have to find the maximum value. Okay, the maximum value for the moment. Okay, the maximum value for the moment. How can we find it? We can find it by using the first derivative of the moment equation equal to 0. Okay, because the maximum value will happen. Okay, for example, if this is the moment distribution like that, the maximum value will happen at the location where the gradient is equal to 0. The moment gradient is equal to 0. In that case, at that particular location, the first derivative of the moment equation will be equal to 0. That's the logic behind that. So we will start with the first thing is to find out the reaction forces at A and at B. Okay. Now I will redraw the free body diagram. The free body diagram is supposed to be like this. Please excuse me if my drawing is not that good as usual, right? And the external reaction, external distributed force is like a triangle like that. Okay, and here the value is 600 Newton per meter. And then we will have reaction force at A, AY, and reaction force at B, BY. And at A, there is supposed to be AX as well. Okay, and as I told you before, in order to find out the external reaction force, we can represent this particular distributed force, okay, this triangle distributed force with one concentrated force. Okay, and in order to find out the concentrated force, we have to know the area under the curve. So for triangle, the area under the curve of triangle will be this multiplied by the length, okay, and divided by 2 because it's triangle. So for this case, it will be 600 Newton per meter. Okay, the represented concentrated force supposed to be F equal to 600 Newton per meter multiply by the total length. The total length will be 3 meters. Okay, and we have to divide it by 2. And the value there is supposed to be 900 Newton. Okay, and where we supposed to put it? We supposed to put it 1/3 from the left in this case. Okay, 1/3 from the bottom of the triangle. So one third of the length will be, so if the total length is 3 meters, so 1/3 of the length will be 1 meter. So roughly around here. So the length here is supposed to be 2 meters. And this is 1 meter. And this is 1 meter as well. And the value is 900 Newton. The next thing that we're supposed to do is to find out what is the value of AX, AY, and BY. Okay. Remember, for each free body diagram, we will have 3 equations: sigma Fx equal to 0, sigma moment equal to 0, and sigma Fy equal to 0. Okay, first we will use this one, sigma Fx equal to 0. But we will got here because Ax is the only horizontal force, so Ax is equal to 0. Then in order to simplify the equation, I will start with sigma moment. Sigma moment at not start. I will do the sigma moment at A next. Sigma moment at A equal to 0. What I will have there will be 900 multiplied by the moment arm 1 meters. Okay, clockwise is positive, remember, in this case, minus Py multiplied by 2 meters equal to 0. In this case, Py will be the same as 900 divided by 2, which is 450 Newton. That's Py. Then using sigma Fy equal to 0, going up is positive. So what I will get here will be Ay plus Py minus 900 supposed to be equal to 0. And remember, we already know the value of Py. So in this case, plus 450 Newton, which is the value of Py, minus 900 Newton equal to 0. Okay, and in this case, we will have that the value of Ay is 900 minus 450 Newton, which is equal to 450 Newton as well. So that's it. We find out that the reaction force at Ay is 450 Newton, and the reaction force at Py, the reaction force at Py is equal to 450 Newton. So the next thing that I will do is to draw the new free body diagram for our cutting process. Okay. Okay, now I will continue with the new free body diagram for the cutting part. Okay. As you can see here, this is our new free body diagram. The distributed force is still there. Okay. And there are two external forces, two external reaction forces, 450 Newton, and another 450 Newton, 1 meter from the right. Okay. And as usual, because I told you before, there will be discontinuity there because of this particular 450 Newton. Okay, that's why we have to divide the equation into two. This is the second cut, and this will be the first cut. Okay. And now, in order to make it easier as well, as usual, I will draw two coordinates to help me to solve the particular problem. The first one is x from the left, is x. Okay, and the second one is from here. This one is x-axis, to make it easier for us to solve the problem. Okay, so later for a second cut, the second cut will be it will works for x between 0 to 2 meter. That's for the first cut, for the second cut. And for the first cut, it will works for x equal to 2 meters until 3 meters. And if we use, in this case, if we use x-axis, yeah, if we use x-axis, it x equal to 2 meters until 3 meters is the same as x-axis equal to 0 to 1. Because at this particular point, okay, the x value is 2 meters, but at the same time, the x-axis value is 0 meters. And at this particular point, at the end, okay, so at this particular point, the x axis will be 0, x will be 2 meters. At this particular point, okay, the x-axis will be 1 meter and the x will be 3 meters, something like that. Seems like I accidentally wipe it out. Okay, something like this. Now I will start with the first cut. Okay. So I will start with the first cut. Remember that this will works for x 2 meters until 3 meters, or between x-axis equal to 0 and x-axis equal to 1 meter. Okay, in the calculation, I will use x-axis instead of x because it will be easier for me. Okay, now let's cut. We cut there, and we will use the right side of the cut because that one is simpler. Always start with always use the simpler one. Okay, that's why what we will have here will be something like this. Okay, so this is roughly the free body diagram, and there will be a triangle distributed force there, and on the left side, as usual, V positive is going down and moment positive is clockwise. Yeah, sorry, not going down. V positive is going up. Sorry, my mistake. Okay, V positive is going up and moment positive is clockwise. Okay, but in order to solve this, we have to know the equation of this particular distributed force. Okay, at this side, at the left side, what is the value of the distributed force at this particular side? Okay, remember that the maximum value is 600, where okay, the W is equal to 600 when X is equal to 0, and the W is equal to 0 when X is equal to 3 meters. Okay, So in this case, we will be able to find the equation for W. Remember that the equation of W is always, because it's linear, it will follow this equation. Okay, and using the first value that we got, at x equal to 0, dW is equal to 600. So A multiplied by 0 is 0, plus B is equal to 600. So in this case, B will be equal to 600. Then using the second one, this one, at x equal to 3, W is equal to 0. So at x equal to 3, this one, plus B. But remember, we already plus B, right? Plus B equal to 0. But remember, we already know the value of B. The value of B here is 600. So just put it there. So our A value will be minus 600 divided by 3. In this case, minus 200. So our final equation of W in terms of X will be minus 200x plus 600. Okay. Minus 200x plus 600. Okay. And now in terms of x action, we have to find the value of W because everything will be in x action. Okay. Remember that the cut here, the distance here will be one minus x action. Okay. So because the variables is x action, we have to find the value of W in terms of x action. The value of W in terms of x action. Okay. What we're supposed to do is just to replace x with x action. Remember that x at x equal to 3, at x equal to 3, x action is equal to 1, okay, and at x equal to 2, x action is equal to 0. So in this case, our x action, I can represent it in terms of x like this, x minus 2 meters. Okay. So in this case, I can replace x here with x action. X will be the same as x action plus 2. Okay, and okay, I will continue again. Okay, so now I can replace x here with x action. So our W will be the same as minus 200 multiplied by x action plus 2 plus 600. Okay, so our W here will be the same as minus 200 x action okay, plus 600 minus 400. So in this case will be plus 200. Okay, let's check at x equal to x-axis equal to 1 meters. The value of W is supposed to be 0, and it's correct, right? So this one is our equation that we're supposed to use in this particular problem. Okay, now we use it to solve the problem. Okay. Now, as usual, for this particular cut, I will do the sigma Fy and sigma moment in order to solve the problem. Okay, but remember, as usual, whenever we have a triangular distributed force, the representative concentrated force, okay, it's supposed to be at 1/3 from the left. Okay, supposed to be 1/3 from the left. Okay, and the value of the concentrated force in this case is supposed to be the value of W at the left side here multiplied by the length. Okay, and in this case it's supposed to be this particular W minus 200 x-axis plus 200 multiplied by the length. In this case, the length is 1 minus x-axis divided by 2. So in this case, it's equal to 200. Sorry, this one is minus 100x multiply with this one is minus 100 x-axis okay minus 100 x-axis square this one is supposed to be plus, sorry. Okay, and then plus 100 minus 100 x-axis. Okay, so in this case, what we will have will be minus 200 x-axis plus 100 x-axis square and plus 100. This is our F there. Okay, and using sigma Fy equal to 0, what we will have here will be if positive is going up, phi minus F equal to 0. That's why our phi will be equal to the F. Okay, in this case it's the same as this one. So 100 x-axis square. I rearrange the terms a bit. Okay, minus 200 x-axis plus 100. Okay, so this is our phi equation. So the phi equation is already quadratic. Now let's do the moment equation. Sigma moment from the left side equal to 0. Okay, in this case, what we will have will be, if clockwise is positive, moment plus F multiplied by 1/3 of the length. So 1 minus x(n) divided by 3. Okay, so our moment equation will be minus f multiplied by 1/3 of the length. So in this case, what I will have will be minus f. So minus x(n) minus 1 divided by 3 minus 1 multiplied by that multiplied by f. In this case, my f will be 100 x(n) square minus 200 x(n) plus 100. It will be to the power x(n) to the power of 3. Okay, so in this case, what we will get will be I think it's better for me to take out the 100 out. 100 divided by 3 out. So in that case, what I will have will be x(n) to the power of 3. Okay, minus 2 x(n) to the power of 2 plus 100 x(n). Not 100, plus x(n). I'm so sorry about this. Minus x(n). Okay, and then using the minus 1 minus x(n) square then plus 2 x(n) minus 100. Then by combining the terms, what will I get will be 100 by 3 multiplied by x(n) to the power of 3 minus 3 x(n) square plus 3 x(n) minus, oh sorry, this one is not 100. This one is 1. Minus 1. So this is our equation. Yeah, it's quite long. Okay, and it will work only for this area. X equal to 2 meters until x equal to 3 meters. X equal to 2 meters until x equal to 3 meters. Okay. For phi, because x(n) is positive, x(n) is positive means that it's open at the top part. Okay, at x(n) equal to 0, the value will be 100 for phi, right? At x(n) equal to 0, the value will be 100, and at x(n) equal to 1, the value will be 0. Correct. Yeah, the value will be 0. 100. So run here 100, and this one will be 0. Sorry, not better not to put it there. To put it here slightly lower. Okay, and remember it's going up. So roughly the graph is supposed to be like this. Yep. And then for this one, at x n equal to 0, the value will be minus 100/3. Okay, and at x n equal to 1, 1 minus 3 plus 3 minus 1. It's supposed to be 0. Yep, 0. So 100/3 when x n equals to 0 is minus 100/3. Minus 100/3 is around 33.3 at the moment. Till it reaches 0. Okay, at this point is supposed to be around 33.3 minus 100 Newton. At this point is minus 33.3. Okay. Actually, in order to draw the graph perfectly, we're supposed to put one value in the middle. For example, at x(n) equal to half. Okay, let me use my calculator. One 1.875 at 0.5. At 0.5, 1.875. So most likely the graphic is supposed to be like this. Yeah, getting closer to 0, like that. At this point, at the end, it's supposed to be 0. Okay. And then the next thing that we're supposed to do is to do for the second cut. So for the x equal to 0 until x equal to 0 until x equal to 2 meters. Okay. For that particular problem, I will use this equation. And instead of using the left cut, this particle cut, okay, I use the right cut. Why using the right cut? Because using the right cut, we know that the concentrated force which representing the triangular distributed force will be 1/3 from the left side. Okay. So I will continue with the free body diagram after this. Okay. So the free body diagram is supposed to be like this. There is a 450 Newton here, and there is a this one is the cutting part, and there is a triangle distributed force like this, and the W value at the left side is minus 200x plus 600. This one is W equal to, at this particular sites, okay, minus 200x plus 600. Okay, following this equation using x instead of using x section, because now we do for the second cut. Okay, remember this is the second cut, and the second cut will work for x equal to 0 until x equal to 3 meters. Now let's try to find the distributed the representative of the concentrated force. It's supposed to be around here, the F here, and the F there is supposed to be representing the triangular concentrated force, and the distance is supposed to be 1/3 from the left. Okay, 1/3 from the left. And remember now, our distance here, instead of x, it will be 3 meter minus x, because x is from the left. Okay, 3 meter minus x. Okay, and in order to make it easier, the distance here will be 1 meter, and the distance from the 450 Newton to the left one, it will be 2 meter minus x, because at the beginning the distance is 2 meter, but on the left side is x, so 2 meter minus x. So this is all the distance that we need. Okay, after this we have to calculate the value of F. Okay, the value of the concentrated force, which is representing the triangular distributed force, is supposed to follow the triangle area. The triangle area is supposed to be this particular part, okay, which is minus 200x plus 600 multiplied by the line, 3 minus x divided by 2. So our F will be minus 300x, okay, plus 900, okay, plus 100 x square, okay, and minus 300 x. Supposed to be like that. Okay, so 100, let me check again. 100 multiplied by minus 100, okay, it's correct. So 300 multiply this, correct, positive. Then this one multiply by this plus x. Okay, this one multiplied by this. Yeah, this one is supposed to be correct. To simplify, let's simplify it. So it's supposed to be 100. I put it outside, x squared minus 6x. Okay, plus 9. This is the equation of f. Now, oh yeah, I forgot about one thing. We're supposed to draw the phi and positive moment. The moment positive is supposed to be clockwise on the left. Okay, the positive phi is supposed to be going up. Okay, the same as this one is going up because it's on the left. Okay. Now, as usual, we can find the equation for the shear force using sigma Fi equals 0. In this case, if going up is positive, what we will have is phi minus F plus 450 Newton equal to 0. Our phi equation will be F minus 450 Newton. So in this case, the equation of phi will be (100 x squared minus 600x plus 450. This is our phi equation. And then using sigma moment on the left equal to 0, we will be able to find the internal moment. And if clockwise is positive, what we will have is m plus f multiplied by the length divided by phi. In this case, phi minus x, the total length divided by phi. Remember, because it's 1/3 from the left. And then clockwise positive, remember, minus 450 multiplied by 2 minus x. Supposed to be equal to 0. Then our moment will be not minus, I like to use minus here, f multiplied by minus 1 multiplied by 3 minus x divided by 3, supposed to be x minus 3 divided by 3. Okay, then what else? Plus 450 multiplied by 2 minus x. Okay, so this is our moment equation. So now if we use this f here, what will I get will be 100 x squared minus 6x plus 9 multiplied by x minus 3 divided by 3. Okay, and after that we will have plus 900 minus 450x. Okay. The moment here we will have is 100 divided by 3 multiplied by x to the power of 3 minus 6x squared plus 9x, okay, minus 3x to the power of 2 plus 6x, plus 18x minus 27. Okay. Plus 900 minus 450x. Let's rearrange the terms. X to the power of 3 minus 9x squared plus 27x minus 27 plus 900 minus 450x. Our moment here will be 100 per 3x squared minus 300, x to the power of 3 minus x squared plus 900x plus minus 900 and then plus 900. That's why we can delete this. Okay, minus 450x. So in this case, it will be 450x plus 450x minus 900x plus 900x minus 450x. So this is it. This is the equation. Okay. Then we have to check at phi equal to 0. What is the value of phi here? The value of phi here will be the same as at phi equal to 0. The value of phi will be 450. And at x equal to 2, the value of phi there will be 400 minus 1200 minus 350. Okay, and then the moment at x equal to 0, the value will be 0. And then the moment at x equal to 2 meters, the value will be minus 33.3. Okay, so here the value will be 450. Okay, and at x equal to 2, the value will be minus 350. Minus 350 is around here. So the jump there will be 450, which is the same as the concentrated force there. So we know that the value is correct. This one, the value of this one will be minus 350. Okay. Then after that, the moment value at x equal to 0 will be 0 here. And the value of the moment at x equal to 2 will be minus 23.3 here. Okay. So because there is no concentrated moment, I believe this value is supposed to be correct as well. Now, the second question is to find out the maximum moment value. The maximum moment value. Okay, using this, I will try to find the dm, the first derivative, dm per dx. Here supposed to be 100x squared minus 600x plus 450. Okay, and it's supposed to be equal to 0. Okay, and if you try to find it out, the length, the maximum later will happen at x equal to 0.879 meter. Okay, 0.879 meters, and the value of the moment maximum okay, the value of the moment maximum will be 186.4 Newton meter. Okay, because it's too complicated to draw the curve here, I will not draw it. So I think that's all for today. So this is how to solve this particular problem. Okay. Thank you very much for listening.